the technology advisor at the MRC, and my focus is around obviously technologies, Industry 4.0, smart manufacturing, however you want to refer to it. But my role is to inform, advise, and help manufacturers implement technologies where it makes sense to drive business improvement. Bosch Rexroth is certainly one of the partners that can enable those technology solutions and improvements. I want to thank you for joining us today. We're very grateful to Bosch Rexroth for providing this series of webinars, 6 in total. Week 1, we started out with sensors, manufacturing sensors. Last week we had IoT Gateway, how you can get the information from sensors on your production floor to the cloud or to wherever you want to utilize that data. Today is condition monitoring with Production Performance Manager we're going to hear about, and that's, what do you do with that data and how to monitor your operations. So it's pretty exciting. There's 3 more webinars in the series that cover things like asset management, asset tracking, I should say, and other topics that are relevant. And all of the prior sessions have been recorded. If any of you would like to receive that recording, if you missed it or you want to share it with someone, so just let us know. Again, I look forward to today's webinar and the future webinars. And at this time, I'd like to turn it over to Andy Hassold, who is a true connected industry expert. Andy?
Thank you, Jeff. Can you hear me?
Yes, we hear you fine. And I just wanted to add one thing, if you don't mind, Andy. As Diane mentioned, we have the chat function. Please feel free to use that at any time, and we'll stop and answer your question. But there will also be Q&A at the end for any questions you may have. Sorry for interrupting you, Andy.
Perfect, not a problem. I appreciate it. Next question, can you see my screen?
Yes, I think we need to put it into slide mode.
Yep, how's that?
There you go.
Excellent. All right, thanks, Jeff. Thanks, Diane, for giving us the opportunity to speak in that series. A couple words to myself. Andy Hassold, as Jeff mentioned, connected industry consultant. My background is in manufacturing and logistics. I'm a industrial engineer by trade. I've been with Bosch for about 15 years now. Held different roles, predominantly around continuous improvement, lean production, helping organization transition with change management topics. And this is where we see Industry 4.0, this new big technology push. How do I apply that in my organization? Just throwing money and technology at the problem is not solving the problem. It is not giving ourselves and our customers the benefit as they expect. So what we'd like to do, and in my job particularly, is to help customers navigate not only the technology side of things, what works best for certain use cases, who's out there as solution providers, as vendors, but more importantly, how do I really leverage technology and solutions in my organization that people adapt to it, aren't afraid to use new things, try new topics, and really drive benefit into the organization. So as Jeff mentioned, we're in part 3 of this series. We heard from Christopher Cook the first week around sensors. Sensing condition, sensing events, sensing performance or parameters in my manufacturing environment is the first step. Enabling equipment and processes to take data, and then in our second part of the series from Alan Tubbs about the IoT Gateway, that we can take that data that has been delivered and recorded from sensors, that we can send that to back-end systems, databases, MES systems, cloud applications, And today in part 3, what I want to talk about is our next seed production performance manager, where we can then, as the next puzzle piece, that we can take the data that your equipment, your process generates, send it up to either an on-premise or a cloud-hosted solution, that you can utilize that information and make better decisions for your operation. Where do we come from? We are a 130-plus-year-old manufacturing company. There's a lot of process knowledge, process depth in our organization. I always tell my customers there's nothing that we don't do as our own company, from molding to assembly to coating processes, machining processes. We have experts in our own organization that we can bring to the table, that I always say we can phone a friend, phone a coworker that has had certain problems. Very process oriented. Started out in Stuttgart, Germany. But where are we today? A lot of technology has come a long ways, and we as a company have started to adapt that and develop more and more technology, not only within our own products that we sell to our customers, but also technologies that we use in our own manufacturing environment. Here in this example from a couple years ago, where we outfitted Robert Bosch's first manual lathe with various sensors. And you can see up here one of our IoT gateways. And through the connection of sensors to the IoT gateway, we can sense the performance and parameters of this old manual lathe. What we can do, we can outfit also older equipment to still give you insights into what is happening. Obviously, it makes it a little easier if certain preconditions of newer equipment or met, data is being made available in certain formats, but don't be hesitant of looking at older equipment on how you can still draw values by applying these puzzle pieces, sensors, gateways, and then performance manager software on top of that. What we see, data. There's a lot of data, everybody has it. Unfortunately, in the past, in many cases, we have it to protect ourselves, mostly from lawsuits, litigations, product defects, and store that stuff away and hope we never have to use it. I want to say most recently, over the last 2 to 3 years, company have been dabbling more into looking what data are they collecting from processes, from products, to turn that data into information that at the end of the day, they can gain insights, actionable insights for their manufacturing experts to make better decisions, to solve problems faster, bring equipment up and running faster. And what we realized, there's a handful of buckets or segments that we keep finding over and over again that we struggle with and would like to have more insights in. Number one is condition monitoring. We would like to understand what is the condition of our equipment, and we want to monitor temperatures, fluids, performance, speeds, feeds of equipment for in milling and lathe application, for example. The other part is what we call process monitoring, where we would like to see where we have a discrete event with a defined start and end date for a time. For example, a tightening process. We want to measure torque over angle. We want to measure in pressing applications, correct depth, how we exerted the proper force over depth, and is that according to our product definition, our process definition, to classify a good or bad event. The third category, we'd obviously would like to have more insights into what is happening and predicting events. We want to have our maintenance application tied into these technologies, giving them the right information at the right time to make better decisions. And lastly, give them tools to manage the workload that they have from an operational and from a maintenance setting most effectively. I'm going to go over a couple of slides that show in theory what we're going to see in a quick live demo later on. If you do have any questions at any time, please feel free to interrupt me, and I'll gladly answer those questions right then and there. So what you see here is we are connecting equipment to our production performance manager by having sensors either already built into the equipment or through the additional installation of new sensors. In this case here, we see oil pressure and temperature, and those values come in value over time is what we're displaying here. And there's a continuous stream of data that we can see and monitor if certain parameters run into a non-favorable condition. From the process monitoring side here, we see a discrete process, a defined torque curve, where we measure torque over angle and get a result back whether or not this process was okay or okay. What makes this solution quite attractive, it does not require any coding to set up a lot of predefined rules that come in this package. We can monitor simple upper-lower limits of temperature, trends, but also look at more dynamic rules where we can detect certain jumps, certain functions within a distributed number of measurements. We have a lot of statistic tools already built in, giving you the measuring your process capability, for example, or machine capability index can be calculated in here. Events, counts, sequence detection, anomalies with certain algorithms are preloaded that only require configuration. We'll go through that in a live example here in a second and show you how easy that actually is. It also allows you to do very complex rules where we can pre-process data through MATLAB, for example, or Node-RED applications, and then send the data and the right piece of information onto the application where you can then apply additional rules to that for information to send to your manufacturing experts. The solution also comes with a built-in ticket management system that allows you to manage for your operational and your maintenance staff to very effectively and efficiently manage these types of deviations that occur in your organization. I'm going to take a quick break here, and we're going to jump over into our live demo. I will change over to another screen here. Any questions so far? No. Please let me know if you cannot see my new screen and what you see. Yes.
Andy, I'm not seeing a display. It's just kind of the meeting screen.
Okay.
There.
Something coming.
There we go. Okay. Now we got it.
Okay. All right. So what I mentioned, condition monitoring. What we're measuring here, we have 3 different parameters: cycle time, oil temperature, and oil pressure that you see in different color-coded curves. And as mentioned, continuously the data the value over time is streaming into this application. We can, for better visualization, click and
Nice.
isolate various different parameters to get more visibility in here. We have a historic view. For example, we come in the morning, I can see data live, but I want to see what has happened. For example, in my night shift, I can come in here. I can see, for example, here we're looking at sometime this morning, 6:24 a.m. I can see what has happened for those parameters. I can basically grab a sequence, click on this, and I can now start diving into what exactly has happened at any given time to analyze and go and pinpoint down to the exact parameter or sensor value that has been delivered at a certain time. Where this comes in quite handy, we want to troubleshoot, we want to have data available to make better decisions on what has happened. In the past, we a lot of times just have maintenance records or operator records. Something has happened. We don't really know what. This tool here allows us to clearly dive into problem solving, analytics from a data-driven perspective. We can go in here, isolate what has happened at a given time to make better decisions, to understand the process, the product, to take the correct measures to correct and get back to a functional state. Jumping over to the next tab, as I mentioned, process monitoring. What we're looking here right now, up top you see these red and green tiles. The green tiles represent a good process, the red tiles represent a NOK process. And on the bottom here, I'm looking at a press application right now. We're looking at force over position on how we are exerting force over the pressing process. And it gives us a clear indication, was this a good process, yes or no? If we click on a NOK process, we can see here we had some stutters and some hiccups towards the end of that process. We can also then grab and kind of look a little more closely what exactly happened in this particular process. We can start comparing processes by overlaying the different process curves. Again, with the result, with the intent to give our experts ability to look at data, to make better decisions, to understand what is happening with the condition or the process of my operation. So I mentioned the topic of rules. We want to understand what is happening, what can I do? I don't want to sit in front of my screen all the time to monitor something. I can't attend continuously to that. I would like to have the software monitor the situation and only inform me if certain thresholds or criteria have been met. So in order to create a new rule, for example, we just click up here, and then I can select one or two scenarios. One where we say a device type. Think about it's a family of process or pieces of equipment. If this is something for all your tightening processes or for all of your milling machines, or if this is very specific to just one particular piece of equipment, one particular press, one particular molding equipment. You can choose if this is applicable for the family or for just a individual piece of equipment or process. The next thing that we do, we now select what do we want to monitor. Let's first select on this machine, we want to measure, for example, oil temperature, and we can then select from the predefined rules that are included, for example, an upper bound on oil temperature. And we can very easily just type in anything above 200 degrees. We would like to have a notification, an alert sent. And the way this works, give this thing a name, oil temp high, for example. You can now give it a code. If you already work with maintenance systems, whether these are SAP PM or other solutions where you manage your work orders, track certain history of maintenance activities, and you already use a coding system, you can apply that in here as well, so you have a reference respectively. You can give it a severity, how quickly it should be attended to, and how quickly it should be escalated. And then we can describe what is actually happening here. Temp too high. For example, on relief valve. Describe what this thing is. The more information you can provide, the easier it will be to troubleshoot equipment failures, deviations, to bring equipment back up and running. The most important part and the best opportunity now here to engage your organization is share your best practices on what do you need to do. I mentioned third shift, weekend shifts, etc., where we may not have all the competencies and capacities staffed to attend to machine downtimes or process deviations. Here's a great opportunity to take your lessons learned from your experts and document them. So you can instruct check first valve number 1 for leakage, and then second, check blockage. Guide your operators, your machine operators, through a process rather than trying to be creative and going out on guesswork.
Right.
Or having to call somebody immediately. Give them some guidance, some tools that they can structurally, systematically walk through a problem. And then maybe we call maintenance. We can add this to our ticket mapping system. And once I hit save, this rule is created. Very simple. Process engineers, operational leaders, shop floor foremen can come in here, define their rules that are relevant for their operation to run smoother, to get equipment back up and running faster, deliver output as you had planned. I mentioned shop floor foremen, for example. One item for them that might be quite interesting is also to look at hits of events, for example. You can very easily measure how often does your machine go into a stoppage mode that the operator, for example, just has to confirm a failure. Something happened to your machine. These micro stops, couple seconds here and there until somebody attends to that. You can create a rule. How often does that happen? For example, within 30 minutes. If that happens more than 10 times, then please send a notification. Creating through these rules early warning systems that you can attend to deviations before they come major catastrophes is very key in bringing up your operational performance.
Hey, Andy.
Yes.
This is Jeff. Sorry for interrupting, but
yes, please.
One of the questions that I had, and I think I'm answering my own question. This system, device status, production performance manager. Obviously, it can send notifications, whether it's email or text. Okay, perfect. That's
Correct.
what I thought. And
yep.
You can, I'm sure, select who gets what type of message. And okay,
yep. That is
correct.
Yep. Thanks for the question. We can take a quick look at that here. For ticket mapping. I can assign tickets to a certain category, that certain events are of mechanical nature or certain things are of electrical nature. And I can create my qualifications that I have in my organization. Can be engineers, can be technicians, quality, electrician, and I can assign them. Where am I here? Can I see myself in here?
Yeah.
I can assign myself certain qualifications. What am I capable or allowed to do? And then I can map my tickets respectively. Very easy to set up. That I can assign certain things to my engineer, and if an item occurs on third shift, please send that item to the third shift technician first before it gets escalated to somebody that is at home sleeping. Doesn't do us any good. So this can all be as a self-service customized by the users. If we're looking into the tickets then, I'll look here at all tickets. They pop in here, open, in progress, resolved. We can go in here, gives me a summary of what is going on, what has happened. I can click into the hint. Well, nobody put anything in here. But I can review what has happened. I can also go into a history. Okay, does that happen before? What is the duration? Who has accepted that? Are there similar tickets? I can go back in and have information now available to make better decisions, rather than going out trying to experiment, a lot of guesswork, doing a lot of trial and error to troubleshoot a problem. I have a database of information now available at my fingertip, that I can search and reference. What have colleagues done previously? What has worked, what hasn't worked, to troubleshoot then and apply these types of actions.
Cool.
So condition monitoring, rules, tickets, all nicely bundled in one package. So if I jump back here, you probably don't see anything anymore again. I haven't figured out how to share multiple screens at once.
There we go.
There we go. All right, let me go back to presentation mode. So this application can be hosted in two ways: cloud-based, Microsoft Azure, Amazon, your private cloud, can also be hosted on-premise within your own IT infrastructure. We need certain connectors that send information from the equipment up to this application. The format that is being used here is called PPMP, Production Performance Manager Protocol. There is equipment out there and becoming more and more a standard in the industry on how the defined protocol is being structured. For example, Porsche has several months ago mandated to all their suppliers any welding, tightening, pressing applications need to be outfitted with PPMP as a format to communicate to other applications. The nice part about this here, from a manufacturing perspective, nobody has a shop that only has one type of equipment and one type of manufacturer. We can go out, Mazak, Mori, Makino, or Mori DMG, they all have similar solutions, usually tailored to their make and models of machines. The solution here is completely process and equipment or manufacturer agnostic. We can connect any milling machine, mills, drills, lathes. We monitor different coating processes, maintenance equipment, compressors, air compressors, chiller units. I want to say the possibilities are endless that you can connect equipment to here. Robots, and that's something I want to go into here in a couple minutes, look at some of the benefits and also use cases that might relate to what you have in your own operation. I mentioned it multiple times. We want to increase as a benefit, obviously, our output. We want to stick to the plan that we had set forth on a given day. We want to manufacture in the right quantity, in the right quality. We want to have our equipment available. And if something does not go according to plan or parameters are trending unfavorably, we would like to have these early warning notifications that we can react to them, that we have a chance at the end of the day to meet and also increase our output. Only good parts is what we can sell to customers, and any bad part, any bad quality part that we produce along the way, obviously will cost us additional effort, cost, and our targeted business result will not be where we need to have them. Because at the end of the day, what we're looking to do is reduce costs of our operations by delivering good parts and more good parts in a given time frame to our customers. So a couple examples, as I mentioned here before, monitoring, for example, resistant welding processes. Improvement of OEE was realized by not having to change the worn tips as frequently, by measuring resistance and also the amperage that has been drawn for the process in itself, saving a lot of spare parts, costs around that end, but also downtime by going off the recommended number of wells, usually per tip, realizing by measuring the condition that we can actually increase by a quarter to a third more wells out of the same tip than we previously had. Tightening as another process. As I mentioned before, monitoring torque over angle. Are we producing a good connection in my process? Am I over tightening? Am I under tightening? What is happening? And I also have results now to back up what exactly has happened, allowing us to better troubleshoot. Is it a certain phase within the tightening program? Is it something with the tightening equipment, and drawing correlations or conclusions from there?
Nice.
Giving maintenance technicians, but also operational leaders, the opportunity to manage their workload more effectively through smartphone applications, for example, giving them the information they need at the tip of their fingers, available either on smartphones or tablets, having the opportunity to browse what is happening really improved the response time to downtime of equipment, trying to find the right information, but having it available when they need it. Condition monitoring, nearly endless possibilities which you can measure. We use that quite extensively in measuring fluids, hydraulic fluids particularly, by installing sensors, pressure differential sensors, measuring, for example, filter condition. Is a filter performing as it is supposed to? Is it full? Rather than having maintenance on a time-based schedule and having equipment taken offline to perform a filter change that may have not been required, saving on labor cost and as well as material cost on one hand, but on the other hand, making sure that the filter still performs its intended function of filtering particles out of the fluid, that we have a good product at the end and don't contaminate with additional particles in the testing process, for example. We also use this solution on a very large scale in our international production network, where we monitor and compare processes and performance for 11 plants globally. All that is possible with a solution like that. You can start small, very diverse portfolio, or you can manage a large-scale manufacturing network as well. In the biggest plant, we have about 1,200 machines connected to this application and monitoring on what is happening on a real-time basis.
Awesome.
I said I have a couple more examples. Let me share that and jump over to another slide deck that I have, just to give you a little more ideas on what is doable. Jump into presentation mode again. So I just mentioned the fluid mode. We're measuring lasers, for example, laser cutting as one, monitoring different parameters, temperatures, fluids, condition of filters, etc. Bringing that data together, defining what rules are required to deliver the right insights for different stakeholders or different parties in this process. Monitoring robots, making sure robots are still performing as planned. Run times, utilization, and having a real-time information available to take better decisions when parameters are trending out of spec. Spindle monitoring, getting an understanding if spindles are wearing prematurely. Spindle maintenance as well as spindle changes. Everybody that does machine knows it is a very labor and cost-intensive undertaking. So by having better insights into what is happening and making adjustments or changes at regularly scheduled maintenance intervals definitely will help improve the bottom line. Cylinder monitoring of various natures. Are they still performing? Do we have leakage? Still the right stroke extension? Different test environments that we can monitor. Here we monitor, for example, cycle time of an EVM process. CNC monitoring, in that when we monitor machines, as I mentioned, spindles as one item, we can also measure now speed, feed, lubrication levels, temperatures, anything around that process to deliver a good product. Cooling systems, think about your infrastructure, motors, pumps, HVAC systems, compressors, getting the understanding how well is something performing. A lot of times it's tucked away in your manufacturing settings that you may not visit on a regular basis. Understanding the condition from anywhere really within your organization, what is happening, a clear benefit to improve the efficiency of your operation. We've also used it for monitoring electrical boxes, seeing if temperature spikes occur to see if there's a performance issue with the equipment happening. I mentioned laser welding before, milling machines, quality, tightening, welding, pressing, calibrations. A lot of use cases, a lot of examples on what is possible to monitor within your organization to get actionable insights in real time, and having equipment, processes, and parameters notify you rather than you trying to have to find these deviations on your own. This would be it from my side. As a third puzzle piece on how you can connect sensors through IoT gateways to a software solution that allows you to get more insights and make better business decisions for your operation. Any questions?
Good stuff, Andy. Good stuff. I don't see any questions on the chat. We covered a lot of ground. I mean, you have so many examples. There really is, it's limitless. And the flexible i4.0, you know, the multi-purpose tool where you can get information, send notifications to an iPhone or a tablet, that's pretty slick, right?
It really helps improve your operations. Getting the right information when you need it.
Yep.
Attending to what is really relevant ahead of a problem becoming a major disaster.
Absolutely. The fact that an individual, whether it's a maintenance person or whoever, you know, someone who's responsible for that value stream, right, can see, you know, get a notification that, hey, you know, temperature's up or piece rates down or whatever the condition is, and it can give them even the details. What is the temperature? You know, what is the throughput rate? What is the torque value, right? It's just amazing, the technology.
And it's getting more and more simple. As you've seen with those rules, there's no programming knowledge required. As an operational leader, you can go in, you can create your own rules, how many times certain events may occur, for example, to get a heads up if you are trending in a certain direction that may not be as favorable, but having the data to back up and take the right steps. Do I need my process engineer to look at something? Do I need to have additional staffing or maintenance technicians come to support that? This is now truly powerful to make those decisions based on data rather than guesswork.
Yeah. I have a question. You know, the system, you know, provides device status, you know, real time, right now data, what's happening right now. But I also have the past performance. You know, I have my historical data, right?
Correct. You can go back, like I said, what happened in the night shift? What happened over the weekend? What happened when I wasn't there? What happened when the last time this occurred? Right. I can go, when did this rule trigger, to not only today, but what did it do maybe 2 months ago? A ticket was issued. I can click on those links and jump right into the data on in the performance. What was the temperature then? And I can bring in other values. Hey, how did they perform? What was my pressure in relation? I can now take a lot better decisions.
Let me take that a little further, and I'm thinking traceability here, and I'm sure with my database I can go back, you know, a year, 5 years, 2 years, whatever, right? So traceability, you know, I'm a manufacturer and I make widgets. Every widget is tested at the end of line, you know, test. for whatever, temperature, RPM, torque, amps, you know, and then if it passes the test, it gets a serial number, gets put in a box and shipped out to the customer.
Mm-hmm.
And then when serial number 125 explodes at the customer complains with the, you know, touch of a mouse, point and click, I can look at the parameters for serial number 125 and see when it was built, what were the, you know, what was the data when it was built. Okay. And then I can use that data to correlate, you know, failures in the field. I may see some correlation that all the failures in the field had a low torque value. And then I can go back into my process and start understanding why does my process yield low torque sometimes, right? And work to improve that. So it's not only the traceability, the convenience, but it also helps with the root cause. You know, so what I'm talking about is easily handled by this technology, right?
Correct. Yep. It provides you additional insights that if you have it available in other systems, it is cumbersome to draw in the correlations between one table and another table. Makes it a lot more user-friendly, a lot more self-serve. I can go back and look at things.
Yep. So I have customers, many customers, you know, it's a large percentage need this type of support, right? Where, you know, paper and pencil just doesn't cut it anymore, right? You know, it could take a week or thereabouts just to dig through the paperwork to find out when serial number 125 was built, and maybe you have captured some of the information. But, you know, with sensors, you know, you have the information, pull it up into the database. I'm sure this can also serve as, you know, well, it's production performance manager. So if I want to know where production lot is, an order, let's say, I can look at my computer from my desk, or even look at my production from my mobile phone to understand, is that production order going to ship today? Is it complete? Is it, you know, this information can provide that type of information as well, correct?
Not quite. Usually that is handled, I want to say, in your MES or your ERP system.
Okay.
Where you have the information available regarding what state of completion a product is in. That is not captured in here.
Okay.
The system here focuses on the condition and the process quality.
I got you. And it will tie into my MES ERP.
Correct.
Awesome.
You can take information as an additional data source to pull from. You can also take that information and send it. The solution has a open API interface. Everything is thoroughly documented on how you can take data from here, send it elsewhere, or take additional data and bring it in as additional data points, for example.
Great. Powerful stuff.
Makes manufacturing life a lot easier. That is for sure.
Yeah. Yeah. Well, that's AMT, Advanced Manufacturing Technology, right? World-class stuff. Yep. Bosch, Rexroth. You know, no one does it better. So again, I don't see any questions coming in. I'd like to you know, thank the team for your attendance and your participation, and remind you that if there's any interest or questions in any of this type of technology in the series that we're doing, please reach out, you know, to the MRC. We can certainly have conversation and try to understand, you know, what your goals are, what you would like to do, what questions you may have, and then help you, you know, implement solutions, or even just consider, you know, what would it take, what would it cost, how long does it take, what kind of support do I need, all those questions. We can certainly help, you know, guide you and support you on your road to smart manufacturing. And again, Bosch is a resource. They've got so much, even with their your I want to call it a display, Andy. I don't know what you refer to your facility.
Yeah, so we have a let's call it a customer. It's more than a customer experience center. You can come to our facility. You can tour our manufacturing line, our multi-product line. This is just one example on how we applied a lot of technology in our own area to solve specific manufacturing problems that aren't that specific to us, but fairly universal to other manufacturers as well.
Yeah.
You can schedule tours with us. We'll have a conversation, see on what would be applicable to your cases, and take a look and talk to the experts that have implemented but also utilize the solutions on a daily basis.
Yeah, it's impressive. It's everything from automated guided vehicles to augmented reality to collaborative robots, active cockpit display. The production performance manager that we went through today. It's the bomb, if you will. It's what everybody wants. So any interest, questions, please reach out and we can help you get there. So
excellent.
We'll be sending the recording and presentation out to everyone. And if you have any colleagues that you think would be interested, we still have 3 remaining topics. Feel free to let them know to sign up on our website. And look forward to seeing you next Thursday. What's our topic next Thursday? Anybody remember? Is it AI?
Asset tracking?
Asset tracking.
I think. I could be wrong.
Yeah, I thought we'd do AI next week.
Oh, there you go.
I can tell you in 1 second. Jeff is right. It's trace and track. AI is on 7.9.
All right, then you have to listen to me again next week.
That's $1, Andy. You owe me $1.
All righty.
Everyone.
I'll buy you a beer next time I see you.
There you go.
Andy, do you have a couple minutes if I call you just to talk real quick?
Did you say Andy?
Yes.
Yes.
Okay.
I do.
All right, I'll call you both.
Okay.
Perfect.
Hey, thanks everybody. Take care. Have a great week. We'll see you next week.
Thank you. Appreciate it.
Bye-bye.
Bye-bye.